Alright, in the previous lesson we looked at simplifying rational expressions. So there were problems like the one shown below here, 2x plus 6 over 4x plus 6. And I tried to emphasize the fact that you cannot cancel those 6's. The only thing we can cancel is factors when we're dealing with fractions. So if I were to factor this thing, numerator factored, it has a 2 that can be pulled out. The denominator has a 2 that can be pulled out. Now the 2 is a factor of the numerator, and the 2 is a factor of the denominator, and those 2's can cancel. They essentially are 2 divided by 2, which is just 1. And so our simplified form would be this expression. Again, we can't cancel out those 3's. Those 3's aren't factors. Okay, so in this lesson now we expand on that, and what we're going to be doing is multiplying 2 or more of these rational expressions as well as dividing them. And so some of these examples are just from the classwork section on the website that we use. So here is the first type of example. Now this is just 8a times 11 over 12a. When you have multiplication in a problem, it automatically makes it a factor by definition. 8a times 11 makes your numerator. And on the bottom, if you'd like to think of the 8a being over 1 times 12a is just 12a. So multiplication makes the 8a a factor, the 11 a factor, 12a is a factor of the denominator. Now we can cancel out anything that is common. Now the a is clear to see that's a common factor for the numerator and denominator. 8 and 11, those aren't factors of 12, but inside that 8 is a common factor of 12. Okay, 12 is 4. Oops, 8 is 4 times 2. 12 is 4 times 3. And so they have that common factor of 4 in them. So you could reduce that to a 3 on top and a 3 on the bottom. Okay, and so you get 33 over 3. Oops, I guess I should have noticed those common factors right there. You get 11. 88 over 12 does not give you 11. Where did I cancel wrong? Oh, that's a 2 on top. That explains that. Sorry, I couldn't read my own handwriting. It's not a 3. Remember, I changed this to a 2 up there. And so that's 2 times 11. 22 over 3, and they don't have a common factor. Now, you would have gotten the same result had you just approached it from, hey, straight multiplication, and gone, well, that's 88a over 12a. A's cancel, so it's 88 over 12. They're both divisible by 4, and you get to that result. But the reason this works, something that we often forget, is because we are looking for these common factors, and we just divide those things away. Okay, so that's a very simple one, and it's simple because the two things being multiplied, well, let's just go to a new slide. The two things being multiplied were just monomials. Let's do one that's a little more complicated. D plus E over F plus 2 times F squared minus 4 over D plus E squared. And we're going to try to move this whole thing if I can. Right there. Now, again, notice this big multiplication right here. What that means is that D plus E and F squared minus 4 are now factors of the numerator. And F plus 2 and D plus E is a factor twice in the denominator. That's D plus E times D plus E. And so now we can start to cancel some common factors, and we can see actually that this D plus E and this D plus E, those can cancel, but there are 2 of these guys down there. So if we just cancel the 1 from the top, we can only cancel 1 from the bottom, which would make it just D plus E to the first power now. This numerator, though, is a difference of 2 squares, F minus 2 times F plus 2. Notice we're factoring them. Why? Because we're looking for common factors. And so you have to have it factored to find them. And we can see now there's a f plus 2 that's a common factor in the numerator and denominator. And so that just simplifies to f minus 2 over d plus e. So here's our original multiplication problem, and the result is a much simpler rational expression. Let's do one that's a little bit longer. Let's do g squared minus 7g plus 12 over g squared minus 9. I cannot cancel those g squareds. They are not factors. They are terms. You get tired of me saying that, but we have to resist that urge to do that. So there's my multiplication problem. Again, let's slide it over just a little bit. And the best method when you see that you've got multiplication going on and you've got polynomials up here by virtue of the fact that they are terms all added together, is just start going factor crazy. So I'm going to factor the first numerator, g and g. To get a 12, I've got to have 3 times 4, and they're both negative, so they add up to a negative 7 in the middle. I'm just going to factor the next numerator right next to it, because multiplication is going to bump them right up next to each other. To get g squared, it's g and g. To get 4, 2 and 2, and they add to give you 4g in the middle. This g squared minus 9 now, that's a difference of 2 squares. This one's a little bit tricky, this one. Everything's divisible by 2, so I can't just divide the 2 away. What I can do is factor it out. That leaves me with a g squared plus 3g plus 2. You could do a little canceling now if you have any common factors that you can see. I'm not quite done with all my factoring, but I can see, for example, that g minus 3 and g minus 3 will knock each other out. I'm not done with my factoring, though, because of this term right here, or that factor. It's got a g squared in it. So I'll continue to factor it. My numerator, g minus 4 stays g plus 2 and g plus 2. My denominator, now I've got a g plus 3. I've got this 2 down here. I'm just going to put that into the front. Since it's all multiplication, I can put these things in any order I want. And I'll factor that g squared plus 3g plus 2. That's how it factors. Again, looking for any common factors, a g plus 2 and a g plus 2 cancel. So it looks like my final result is g minus 4, a g plus 2, a 2, a g plus 3 times a g plus 1. And lots of students have asked me, hey, can we leave it in this form, or do we have to multiply all this stuff back together? For right now, I'd say it's just fine. Leave these things in their factored form. It tells us a few things when it's in factored form. For example, I know g can't be equal to negative 3 and g can't equal negative 1 because that would cause division by 0. So that's how we multiply these things. It's really multiplying two fractions together, and then we just simplify them. All right, let's look at one division problem, and we'll see why we only have to do one of these, because it is so similar to the multiplication technique we just looked at. These are L's and K's in this problem, not my first choice. 2k plus 3L over k squared minus L squared. And the way we deal with division is we change it to multiplication and multiply by the reciprocal. So my first step is to rewrite my first factor in this problem. I change it to multiplication, and now I flip the other fraction over. So we're multiplying by the reciprocal, if you remember that from your fraction days. And once we've done that, now it's just like the previous problem. The first factor on top is the k plus L. It's a factor because it's being multiplied times this other numerator. I'm going to factor that other numerator. That's a difference of 2 squares. So there's my entire top of my fraction. On the bottom, I factor this trinomial. and k, l, and l both positive, and 2k plus 3l, nothing in there to factor out. So everything looks like it's factored there. K's are to the first power, so k plus l will cancel k plus l, and that one will cancel that one, and all I'm left with is k minus l over 2k plus 3l. And that is how we take care of division. Change it to multiplication and flip it over. Use the reciprocal.